fogs have the potential to provide an alternative source of fresh water in dry regions and can be harvested through the use of simple and low-cost collection systems. Captured water can then be used for agricultural irrigation and domestic use. Research suggests that fog collectors work best in locations with frequent fog periods, such as coastal areas where water can be harvested as the fog moves inland driven by the wind. However, the technology could also potentially supply water in mountainous areas if the water is present in stratocumulus clouds, at altitudes of approximately 400 meters to 1,200 meters. According to the International Development Research Center, in addition to Chile, Peru, and Ecuador, the areas with the most potential to benefit includes Atlantic coast of southern Africa, South Africa, Cape Verde, China, eastern Yemen, Oman, Mexico, Kenya, and Sri Lanka. What is fog harvesting? Fog harvesting provides an alternative source of fresh water through a technique that is used to capture water from wind-driven fog. Fog harvesting systems are typically installed in areas where the presence of fog is naturally high, typically coastal and mountainous regions. The systems are usually constructed in the form of a mesh net, stabilized between two posts that are spread out at an angle perpendicular to the prevailing wind carrying the fog. As the wind passes through the mesh, drops of fresh water forms and then drip into an underlying gutter, from which pipes lead the water into a storage tank. Fog harvesting technology consists of a single or double-layer mesh net. It will be supported by two posts rising from the ground. Mesh panels can vary in size. The ones used by the University of South Africa in a fog harvesting research project had surface area of 70 square meters, whereas in Yemen, a set of 26 small standard fog collectors of 1 square meter were constructed. The number and size of meshes chosen will depend on the local topography, demand for water, and availability of financial resources and materials. The material used for the mesh is usually nylon, polyethylene or polypropylene netting, also known as shade cloth, which can be produced to various densities that are capable of capturing different quantities of water from the fog that passes through it. The collector and conveyance system functions due to gravity. Water droplets that collect on the mesh run downwards and drip into a gutter at the bottom of the net, and then from there they are transported via pipes to a storage tank. Typical water production rates from a fog collector range from 200 to 1,000 liters per day, with variability occurring on a daily and seasonal basis. Efficiency of collection improves with larger fog droplets, higher wind speeds, and narrower collection fibers. In addition, the mesh should have good drainage characteristics. Water collection rates from different fog collection projects are as follows. The project, University of South Africa, have a total collecting surface of 70 meters square and collects 3,800 liters of water per day. The project, Yemen, have a total collecting surface of 40 meters square and collects 4,500 liters of water per day. The project, Cape Verde, have a total collecting surface of 200 meters square and collects 4,000 liters of water per day. The project, Dominican Republic, have a total collecting surface of 40 meters square and collects 4,000 liters of water per day. The project, Eritrea, have a total collecting surface of 1,600 meters square and collects 12,000 liters of water per day. Storage facilities should be provided for at least 50% of the expected maximum daily volume of water consumed. For agricultural purposes, water is collected in a regulating tank, transferred to a reservoir, and then finally into an irrigation system that farmers can use to water their crops. Drought caused by climate change is leading to reductions in the availability of fresh water supplies in some regions. This is having an impact on agricultural production by limiting opportunities for planting and irrigation. Fog harvesting provides a way of capturing vital water supplies to support farming in these areas. Furthermore, when used for irrigation to increase forested areas or vegetation coverage, water supplies from fog harvesting can help to counteract the desertification process. If the higher hills in the area are planted with trees, they too will collect fog water and contribute to the aquifers. The forests can then sustain themselves and contribute water to the ecosystem, helping to build resilience against drier conditions.